Good morning, sir. I am Avinash Hazarika, and today I am going to present on the topic of dye-sensitized solar cells. So, we all are familiar with the commonly used silicon-based solar cells, but today I am going to present on the topic of this dye-sensitized solar cells as it has been under high demand in the past few decades. And these dye-sensitized solar cells belong to the category of thin film solar cells, which have been under extensive research due to their ease of production or simple preparation methodology or the cost factor. So also the efficiency of this dye-sensitized solar cells is 12%, but it is still less than that of the first and second generation solar cells, that is the silicon-based solar cells or other thin film solar cells, which provide efficiency up to 20 to 30%. So this is the introduction part. So it has simple preparation methodology, and it is low toxic, and it is production of it is easy than that of others. So there is a lot of scope of also there is a lot of scope for a replacement of current DSSC materials due to their high cost, and it can be minimized, and the less abundance and long-term stability, and the efficiency of it reaches up to 12%, and using aluminum dyes, and but other thin film solar cells offers us up to efficiency of 20 to 30%. Now, what is dye-sensitized solar cells? This dye-sensitized solar cells is a photovoltaic solar cell, which changes sunlight directly into electrical energy, and it operates in the low light condition, even in the indoor lighting. So it was given this name because it simulates the process of photosynthesis by absorbing natural light, and these dye-sensitized solar cells can produce electricity under low light conditions, and due to their structural design and different color of the dyes, the cell features colors and tests. Now, coming to the construction and key components of the DSSC, there are four key components of the DSSC material. That is, the first one is the working electrode, which consists of the conducting glass plate, um, which consists of this conducting glass plate and the titanium dioxide semiconducting material. This is the working electrode. And the second one is the photosensitive material or the dye, and the third one is the redox mediator or the electrolyte, and the fourth one is the counter electrode. So these are the four key parameters or components of a DSSC: the working electrode, the sensitizer, the redox mediator or the electrolyte, and the counter electrode. So here we can see that this conducting glass plate, when this light passes through this light can passes through this conducting glass plate. So there are some requirements for this conducting glass plate or the conducting material. That the first requirement is that it should have more than 80% of transparency, so that the light can easily passes through it to the required area of the cell. And the second requirement is that it should have higher electrical conductivity, so that the energy loss due to heat is reduced, and the electrons can move through this material effectively or easily. So the mostly used conducting glass material are fluorine doped tin oxide and the indium doped tin oxide. Here in this figure, the fluorine doped tin oxide, that is FTO, is shown. And now coming to the titanium dioxide semiconducting material, it is this as a semiconducting material in DSSC. This titanium dioxide is mostly used because it is non-toxic, and it is easily available or less, and also less expensive. So, and there are some requirements that it is used in case of dye. So if I should tell about that, yeah, titanium dioxide semiconducting material, it can absorb only in the only a small fraction of the sunlight in the UV region. So to increase that absorption spectra, it is immersed in a photosensitive molecular material, that is a dye. For example, that dye should be blackberry juice or another kind of dyes. So it is immersed in that dye, so that the absorption spectra is increased. Okay, so now coming to the dye. So the dye should, there are some requirements. So for a dye to be used in a DSSC material, so this dye should be luminescent. At first, this dye should be luminescent, and the absorption spectra of the dye should be around the ultraviolet region and the near infrared region. And the highest occupant molecular orbital, which is this is the highest occupant molecular orbital of the dye, should be far away from the conduction band of this conduction band of the titanium dioxide molecule. This highest occupant molecular orbital of the dye is far away from this conduction band of the titanium dioxide molecule, and the lowest unoccupied molecular orbital of the dye, which is this excited state, should be as close as to the conduction band of the dye. And also the highest occupied molecular orbital of the dye should be lie lower than that of the redox electrolytes. Here we can see that this is the energy graph. So the this is at lower energy than that of the redox electrolytes, as it is evident from this graph, right? So now coming to the electrolyte. Now coming to the electrolyte, this electrolyte has five components. First one is redox couple, second one is solvent, third one is additives, and the fourth one is ionic liquids, and the fifth one is the cations. So uh, now this electrolyte also has some requirements that has to be fulfilled in to be used in the DSSC. Okay, the first requirement is that this electrolyte should be able to regenerate this ground state of the dye effectively, and the second requirement is that it should be thermally or electrochemically stable, highly stable. So, and now the absorption spectra of this electrolyte should not overlap with the absorption spectra of the dye. So now coming to the counter electrode, this counter electrode reduces the redox electrolyte and act as a catalyst, and it absorbs the holes. Okay, so these are the basic idea of the four components of the DSSC. So now coming to the next slide. First of all, the first component is transparent and conductive substrate. There are two transparent substrate, one with the working electrode and another with the counter electrode. Okay, so with two sheets of conductive transparent materials which help as substrate for the deposition of the semiconductor and the catalyst, and this also act as a current collectors, as the electrons transferred only through this conductive substrate. Okay, now coming to the working electrode, this working electrode is consist of a thin layer of oxide semiconducting material, that is titanium dioxide. In this case, we have shown the titanium dioxide molecule. Also, there are this kind of other semiconducting materials that can be used, but this titanium dioxide is mostly used as it is non-toxic, as I had mentioned earlier. And along with that, a transparent conducting glass plate made of fluorine doped tin oxide or indium doped tin oxide is used as a working electrode. Okay, so now coming to the this figure which shows the different parts of the DSSC. This first one is the conductive glass plate, and this is the conducting layer, and this blue one is the titanium dioxide which is immersed with the dye, so that it can increase the absorption spectra of the titanium dioxide molecule or the semiconducting material. This orange one is the electrolyte which helps in regeneration of the ground state of the titanium dioxide molecule, and this black one is the carbon which acts as a catalyst in the reduction of the I3 minus ion to the I minus ion, which I will be explaining in the later part in the working principle. And this one is the another glass plate. So these are the parts of the DSSC in a systematic way. So now coming to the next slide. So the next component is the photosensitizer or dye. This photosensitizer or dye increases the absorption spectra of the titanium dioxide molecule. So dye is the component of DSSC that is responsible for the maximum absorption of the incident light. So now coming to the electrolyte. The electrolyte is maybe of I minus I3 minus couple or Br minus B2 minus couple, or like this. So but this I minus I3 minus ion is mostly used, and as I had mentioned earlier, it has five main components: the redox couple, the solvent, the additives, the ionic liquids, and the cations, right? And now coming to the counter electrode. This counter electrode in DSSC are mostly prepared by using platinum or carbon, but as platinum is highly expensive, or it is more expensive than that of carbon, so mostly carbon is used. And both working and the counter electrodes, both working, which is at the top, which I had discussed earlier, both working and the counter electrode, this is the counter electrode, are sealed together, and subsequently an electrolyte which should be used is filled with the help of a syringe in the practical method, right? So these are the components of the DSSC. And now coming to the working principle of the DSSC. The working principle of the DSSC material consists of four basic steps. That is the absorption of the photons and the ejection of the electrons, and and after that the transportation of the carriers, and uh, the last one is the collection of the current through the load. So the four basic steps are light absorption. This is the light absorption, electron injection, transportation of carrier, and the collection of current. So in the first step, when the sunlight passes through this conducting glass plate and reaches the photosensitive material, the electron in the ground state is prompted to the excited state. So, okay, so this is the first step. Okay, it gets prompted to the excited state. After that, this excited electron, having a lifetime of nanoseconds, is injected to the conduction bed of the titanium dioxide molecule, which is just below the excited state of the dye molecule, or the photosensitive molecule. Okay, this is the second step, and the titanium dioxide molecule also can absorb a small fraction of the light in the UV region, and after this electron injection, this dye molecule gets oxidized. Okay, this is the second step. And after this second step, this is an injected electron passes through the titanium dioxide nanoparticles and diffuses towards the back contact. This is the back contact, and it passes through the nanoparticles of titanium dioxide, and through this way it diffuses towards the back contact. Okay, and through the external circuit, it can reach to the counter electrode. This electron can reach to the counter electrode, and after reaching this counter electrode, this electron reduces I3 minus ion to I minus ion, which is present in the redox electrolyte. This for example, we take this redox couple as I minus I3 minus. So this electron that is transferred through this external circuit is which reaches the counter electrode, reduces I3 minus to I minus ion, and after that this I minus ion reduces the or we can say that helps in regenerating the ground state of the dye by providing the electron, and after it provides the electron to the electron, it again oxidizes to I3 minus ion. So this electron that is being transferred to the external circuit reduces I3 minus to I minus ion, and this I minus ion again, sorry, reduces I3 minus ion to I minus ion, and this I minus ion again releases the electron to regenerate this ground state, and after releasing the electron, this I minus ion oxidizes to I3 minus ion. So this is the third step. Okay, and after that this I3 minus ion again diffuses towards the counter electrode, and it reduces to I, or we can say the iodine ion. So this is the four basic steps, that is the light absorption, which is the first step, then electron injection, which is the second step, and the transportation of carrier, and the on the regeneration of the ground state of the dye, and the fourth step is that the uh, regeneration of the iodine ion. Okay, this is the basic working principle of the DSSC. Now this is the animation of the DSSC. So these photons are injected, and these dimolecules get excited, and electrons are injected through the outer circuit, and through this electrical device or load we can extract the electrical energy. Okay, so now coming to the applications of DSSC, this DSSC are due to their structural design and different color of the dyes. This cell features colors and transparency. Okay, this can be, so therefore this can be used in architecture, electronic devices such as to charge the mobile phones, and for also for portable power systems. The first commercial application of DSSC was in 2009. It was used in the backpacks and bags in Hong Kong, where this is the picture of this backpack. This is the panel that is being used in the backpack, and it can be used to recharge the mobile phones or any other small electrical portable devices. So these modules can be inexpensively built to power generating windows or billboards, and we can use that in windows of a house to supply energy to the home. Okay, and also they can be used to coat the lenses of sunglasses and provide power to small device batteries, because the efficiency is quite low, as we had mentioned earlier that efficiency is 12%, so it can power the small device batteries. And the military also is also interested in this technology, as they can use to power a few lights or a laptop in their tents or in their camps using DSSCs. So now this is a representation of the DSSC. Okay, now at first, on a larger scale, these solar panels can be used to cover tents to power sophisticated equipments, right? And after that, these lightweight wearable solar panels could be used to power and recharge the electrical devices that the military carry, instead of carrying the bag full of batteries, which is quite heavy, right? So this is a lightweight solar panel, so it can be easily portable. So this, as we can see, that this is a small device, and these are the two terminals through which the electricity is extracted. And this in this part there are two conductive glass plates, and inside of this and between these glass plates there are the dyes and the electrolytes, and through these external circuits we can extract the electricity. Now coming to the advantages of the DSSC. DSSC have a good depth in their nanostructure, and they absorb the photons in the sunlight well. So I had mentioned earlier that it is this name, dye-sensitized solar cells, have come because it is similar to the photosynthesis process. So as it can absorb the photons in the sunlight well, and the dyes used in the cells are effective in converting the absorbed photons into electrons. Okay, and as we have seen in the working principle. So the generally peak power production efficiency of dye-sensitized solar cells is about 11% or 12%, making them suited to low density applications. If, for example, don't need not we not we don't require such high voltage of uh, energy, so we can use these dye-sensitized solar cells to low density electrical appliances. Although the effectiveness of DSSC is less, but the price to performance ratio attained through these solar cells is greater than other cells, because the price is far below than that of the other silicon based solar cells or other thin film solar cells. So the price to performance ratio is greater than that of the other thin film or silicon based solar cells in case of DSSC. And these DSSC are composed of low cost materials, and because of which DSSC are less costly than that of the other semiconductor cells. And coming to the other advantages, the solar cells can be printed on any flexible surface, like we had mentioned earlier. It can be printed on the backpacks, or it can be printed on the windows, or it can be printed on the sunglasses. So it can be printed on the any flexible devices. So this is an advantage of the dye-sensitized solar cells. And it can also function in the cloudy weather or in the low light conditions, as I had mentioned in the introduction part, that it operates in the indoor lighting also. So the other conventional cells would not succeed in illumination below a certain range. So in that low light condition, other cells will not operate properly, but this DSSC can operate in that cloudy weather or in that low light conditions also. And now, as the temperature rises, in case of other cells, they need to be they need a protection, and they need to be covered by a glass box in case of silicon cells. But these cells, these DSSC cells, uh, doesn't require any protection, because they are made of only a thin layer of plastic, because of which they can easily radiate the heat away, reducing the internal temperature uh, of the DSSC. But in case of silicon-based solar cells, these cells heat easily, therefore the efficiency is greatly reduced because of the internal temperature. But in case of DSSC, the internal temperature is reduced by radiating the heat easily. Okay, so this is an advantage of the DSSC over other silicon-based solar cells. Now coming to the disadvantages of this DSSC. The major disadvantage of the DSSC is the liquid electrolyte that is used in the construction of the DSSC, because at low temperatures this electrolyte can freeze. Okay, and it can affect the power production and potentially leading to physical damage of the structure of the DSSC. And this is a major disadvantage of the DSSC. And now coming to the other disadvantages, this another disadvantage is that it is the ruthenium dye that is used, or the platinum catalyst that is used in the counter electrode, or the ruthenium dye that is used, are highly costly, and the conducting glass plate are also costly. So we need to look for other alternatives so that this disadvantage can be removed. Okay, so now the third major drawback is that the electrolyte solution contains volatile organic compounds. Okay, the electrolyte solution like the I minus, it minus, or other electrolyte solutions contains volatile organic compounds, solvents, which must be carefully sealed. Okay, they should be carefully sealed so that the hazardous material should not affect our human health or the environment. So these are the three disadvantages. The major disadvantage is the use of the liquid electrolyte, and because at low temperature it can freeze. And the another disadvantage is that the cost of the dye or the catalyst or the contact glasses or the conducting glasses. And the third major drawback is that it can the volatile organic compounds in the electrolyte can affect the human health and the environment. So this is the basic idea or the basic presentation on DSSC. I had also discussed about the advantages and the disadvantages and also the working principle of the DSSC. So in spite of these advantages, it is not comparable to the silicon-based solar cells, as it offers low efficiency, around 12%, but other silicon-based solar cells or thin film solar cells can provide us efficiency up to 20 to 30%. So in spite of these disadvantages, the it is still attracting the attention of the researchers, and we can hope that it can be used in future times in a more effective way. So this is the basic presentation from my side. Thank you so much.